Girls, today I'm going to talk to you about air masses and fronts. I have two PowerPoints to go through with you. They may seem a little bit redundant because some of them say the same things, but I figured it did not hurt to have that information more than once. Okay, so air masses and fronts. Those seem like kind of scary words and words that we don't really understand. But I really encourage you guys to watch the weather sometime during the day, or maybe even log on to a news website and watch their weather whenever you get a chance, because they use this vocabulary a lot and then it becomes more familiar to you. Okay, so an air mass. An air mass is a large stationary. Okay, that means it's staying right there. A large stationary body of air that takes on the temperature and humidity from where they form. Okay, so wherever they're made up of, they're kind of pulling that up with them. Now, a front is that boundary between two air masses that moves. And you're going to always see some weather at a front. All fronts are attached to low pressure areas. Okay. All right, so air masses in North America, y'all have this exact anchor chart, or this exact note sheet, I guess I should say. You're going to hear continental polar, continental tropical, maritime polar. All right. Air masses that are formed over land are dry. Those are your continental ones. They're over the continent. That's land. So that means they're dry. Okay, but ones that are over the ocean are the maritime, like marine life, maritime. They're humid, wet, and moist because they're formed over the ocean. So they're being, like that last slide said, they're taking on the type of things that are where they were formed. They're formed over the water, they're going to be wet. Okay, air masses that are near the poles are cold, like we've talked about. The poles are in the coldest climate. Air masses that are formed near the equator are hot or warm. They're in the tropical, just like we have our tropical climate zone right near the equator. Okay, so this is just an example of where we're seeing different ones. This is made over the water, but it's in a cold region, on and on. Okay, so here's an example of a warm front. So you see that warm front. When you see that on your map, the temperature is going to go up, the humidity is going to go up, the air pressure is going to go down though. Okay, a warm air mass replaces a cold air mass when it's a warm front. So sometimes warm replaces cold, sometimes cold replaces warm. But it's called a warm front when the warm overtakes the cold. Now, it moves slower. Warm air slides in over that cold air, and that forms that nimbus stratus, or just plain old stratus clouds. That results in long periods of steady rain. It could also be steady snow. It depends on how cold, it is in there. But these warm fronts are producing kind of the not like storms. Those are more steady type rains. And after the front passes through, the air temperature will be warmer. After that warm front comes through, because it took over that cold air. Okay, cold front. This is when cold air replaces that warm air. And these move faster. This cold air can push that warm air up quickly, and that causes those cumulonimbus clouds. Remember, cumulus are the big puffy clouds, but when those big puffy clouds are stormy, they're called cumulonimbus. and that makes the severe weather. So that's when you're going to have stormy weather, not necessarily just drizzling. This is going to be your stormy stuff. After the cold front passes, the air will be cooler. Okay, so here's an example of a cold front on a map. Temperature is going to go down, humidity is going to go down, and the wind is going to go up. All right, stationary front. And you have a note sheet like this to put in your science journal today. Stationary. If something is stationary, that's where it's at. These are a boundary between two air masses, and it does not move. They're stationary. So whatever that weather is, it's going to be unchanged. So if it's raining, it's going to keep raining. If it's nice, it's going to stay nice. Whatever that weather was, it's kind of stuck there when this stationary front comes. So that's what that means. So stationary doesn't necessarily mean good weather, bad weather. It means whatever's there, it's going to stay there. So you can see this picture. It's kind of like a brother and a sister. They're fighting, and neither one of them will move. Neither one of them will give it up. They're staying right there. Okay. We also have occluded fronts. Okay, a faster moving cold front overtakes the slower warm front, and the cold air pushes that warm air aloft, and it makes a lot of clouds, and it can make rainy and stormy weather. You'll see these on the weather, and they it's kind of like they're mixing together. Where stationary it wouldn't move, these have kind of come together, and that's why we see it as that purple. It's like that red and that blue have come together to make that. So we can see that right here in our picture. You have a paper that shows these symbols. Cold front, it's always moving in the way of the way that those symbols are pointing, just like the warm front. Occluded, it's showing that it's both. Stationary, you've got one pulling this way and one pulling the other way. That's just kind of a reminder of, oh yeah, that's the kind that doesn't move anywhere. And I did give you guys a picture of a weather map like this. Changes all the time, but here you can see high pressure, low pressure. You can see the fronts coming through. You can see the weather right here. Do you see this cold front? And you can see this rain right here on it. Okay, when you see those fronts, some type of weather is happening with it. All right, and then I also want to pull up this PowerPoint. Okay. Again, like we said, an air mass, large region of the atmosphere where it has those similar properties, wherever it was formed at, and they're named by where they came from, like we already talked about. So like in the Gulf of Mexico, that's really warm water, and so whatever's formed over that is going to be warm and moist. Okay, so you can see this picture here, and we can see another visual of the types of air masses depending on where it's at. Okay, but also to talk about winds. So once an air mass is formed, it moves by global winds. In the United States, this is so important. We're going to see this a lot. Winds blow from west to east. Okay, so if we're picturing the United States, I'm going to look back at this map. Winds come from over here to us. That's why a lot of times we see our weather move across the United States. It doesn't always, but weather moves from west to east. That's very important, something that you're going to hear a lot and be asked questions about a lot. Okay, here we are right here. This is the United States. Do you see that wind? West to east. Trade winds are the winds at the equator in this tropical zone. They're warm and steady, and they blow continuously. You can also see them here on our map. So like here is the equator. We can see these trade winds. They're going in the opposite direction of how ours are going. Okay? There are prevailing westerlies, prevailing easterlies. Westerlies are winds that blow from the west, so guess what? We have prevailing westerlies. See, and it says it right there. Here's the United States. We have those prevailing westerlies. That's also important for you to remember. And we have a video explaining about that too. So, obviously, westerlies blow from the west, then easterlies are going to blow from the east. And that is at our polar regions. The jet stream, you may have heard a meteorologist talk about this. You may have heard somebody talk about this if they're going on an airplane. A current of rapidly moving air is a jet stream. Now, the jet stream also moves from west to east across the United States. You see this here. Wherever it's at is going to be the place that has the biggest contrast in its temperature. All right? Now, the jet stream always moves from west to east, but it's not necessarily always in the exact same spot. Colder air is above the jet stream. Warmer air is below it. Okay? I think of, up north it's colder, down south it's warmer, whatever it helps you. But there's always warmer air below it and cooler air above the jet stream. All right, so fronts. A front forms along the boundary between warm and cold, like we already talked about. Remember, you see or hear about a front, that means there's going to be some weather happening. They cause rainy, unsettled weather. Like we already talked about, cold front. It's when that cold air moves under that warm air, that's when you're getting that heavy storm. Of course, a cold front causes some cooler weather. Now, just because it's a cold front doesn't mean it's going to be freezing cold. It just means it's bringing the temperatures down. Warm front is when warm air moves over that cold air. That's when you're going to get that light rain or snow. And afterwards, the weather is warmer. Again, just because it's a warm front doesn't mean that it's going to necessarily be hot. The temperatures will just be higher than they were. Stationary, like we said, when they stop moving, they are parallel to one another. It remains the same. I think about it like a fight. Neither one of them will move. They'll just be stuck right there. They will not move. All right. So those are the two PowerPoints I wanted to show y'all about this. Make sure you watch our videos for the rest of our information today.